The COD editor is used to create and modify diagnostic datasets, which DiagRA D uses to perform non-standard operations on controllers. An expert diagnostic specialist, along with a complete diagnostic specification, are needed in order to develop a diagnostic dataset using the COD editor. Also, as you will see, this is a complex tool, which is very powerful, but not so simple. However, if these resources are available, the COD editor will allow communication with the controller to be completely configured. As long as you have the diagnostic specification and a qualified engineer to set up the configurations, you can use the COD editor to bring DiagRA D's powerful diagnostic capabilities to any platform. Raw Automotive is also capable of creating these diagnostic datasets as a service for our customers. Now, let's dive in. We'll be creating a new dataset from scratch to match our existing simulated project for an MED17 controller. First hit Dataset and then New to create a new one to work with. If we click here, we can see we have some default information already entered here. Most of these will be left default for this demonstration. However, let's go ahead and change the name as well as the dataset path, which will be our naming convention within DiagRA D. And if we hit apply, we can see our changes have been acknowledged. Great. Now let's add the standard fault codes by right-clicking on fault codes and clicking Add Obd Standard Codes. This will allow us to import our needed standard Obd fault codes from the internal database and add them to this project. We can also use our own fault codes if desired, provided we follow the correct formatting requirements. We can attach any DTC we see fit and provide an appropriate name. Here we can see the command used for fault read. We have the ability here to change the status mask. This will change which faults should be shown. We can then add the standard status bits for the bit mask by right-clicking DTC status bits and clicking Add Standard Status Bits. We also have the ability to add our own status bits here. I'm going to also go ahead and add the standard conversions here, as we will need these in just a second. You can see there are quite a lot of these here. Now let's right-click on Current Data and click Add Group Data. We can see a lot of default data being filled in for us, but we'll need to change some of this now. For starters, we'll need the DID. Unfortunately, I don't remember it. So I'll try FF42 for now. Let's also give this an appropriate name and comment. Then we're going to need to assign a conversion ratio to this value, as we do not want to read this as raw hex. Let's choose linear and something related to voltage. Click Apply to set these changes in the database, and then finally, let's right-click on our engine to see there are several other tests that can be added and procedures, though these are not shown by default. But let's save this and give it a try. We can see a prompt telling us to create this, and we can see it appears as though we have created it. So let's launch DiagRA D and give it a look. Once DiagRA D is open, simply hit File, and then select Diagnostic Dataset, and then we can look for our new dataset. You can see my tests dataset is right there. Once selected, we can go online and test whether we use the right values. We'll go online and select our data from the list to read. Oh no, It looks like we have no data from the ECU. That's no good. We must be looking at the wrong address. No problem. I can find it here based on the previous project. Ah, it appears it's F442, not FF42. Well, that's an easy fix. Let's close down DiagRA, and we can make that change now. So, simply make this adjustment here to the DID, apply, and then save the dataset. Receiving the same prompts. We make sure our original dataset is selected. We go online, select our data. We can see the change has been made. We add it. Oh boy. Well, we've got a value now, but it doesn't appear to be right. Something else is still wrong with this. So let's take a look. We have a few options for voltage conversions here. Maybe it's possible we're using the wrong one. Let's try selecting a different one. That should do. And hit apply. Ah! Yes, this data is 2 bytes long, so that is definitely contributing to the problem. Make sure you have the correct data bytes length. Let's save this and give it another try. You can see we're already up and running, so let's just go online. Alright, we're making progress here. It seems that now we just have a 0 in the wrong place. I think the previously selected conversion was correct. We just were missing the extra byte. Let's give this one final try. And if we go online, we'll see that indeed 11.803 volts. That is the correct voltage for this project, so this was a success.